Hello everyone, welcome to the NN Classroom. Today I'd like to share with you a past paper question related to topic 16, the rate order deduction, right? In terms of the kinetics area. Question number 20 in 2018 time zone 1 May paper. Let's see. The reaction between the NO2 nitrogen dioxide and fluorine F2 gives the following rate data at the certain temperature, right? So let's see. So that means here I'm now undergoing three set of experiments, right? And having three different sets of kinetic data. Okay, asking the overall rate order of this reaction. Surely this is not a kind of difficult question, but the way to do so, remember, is always be the first time we do it, we set up the relationship. As from the rate equation that demonstrate rate equals to K times all the reactant to a corresponding power n called the rate order. So in this case, the rate will be equals to K times the two reactant given. One will be the NO2, I call it X to the power. So that is the rate order with respect to X, with respect to NO2, and then F2 to the power Y. So Y will be the rate order with respect to the fluorine. So that's why our target is try to find out what's X and what's Y. So remember, the skill is every time look for one pair of experiment. Yeah. And the way to choose the pair of experiment is that we only choose the pair of experiments that having one substance or one reactant that is changing concentration. Otherwise, we cannot draw the conclusion. Now, let me demonstrate to you. So for the case of these three experiments, what I'm going to do is if I want to find X, the order with respect to NO2, I'm going to find the pair of experiments in which only NO2 has changed the concentration, but not fluorine. So in this case, you will realize experiment 1 versus 2. In this case, if I select these two, I can deduce the order X with respect to NO2. Why? Because you see, fluorine is not participating. The concentration doesn't change, right? So that means any change in terms of the rate of reaction must be due to me changing the concentration of this only reactant, right? So that's why we can never choose the experimental pair in which both the reactants are changing concentration. Otherwise, we cannot get a suitable conclusion of whether it is A or B that leads to the change in the rate, or both actually, right? So that's why in this case, if I choose experiment 1 versus 2, fluorine is kept unchanged, and so the concentration of NO2, let's see, from 0.15 to 0.3, it is going to be times 2, increased by a factor of 2. And this increase by a factor of 2 will bring the rate to be increased by 4 times, right? As you can see, from 0.1 to 0.4. How we interpret 4 times? 4 times is actually equivalent to 2 to the power 2. So that means if you double the concentration, the rate will be quadruple. Quadruple in this case means to the factor of 2 squared. So that means this is going to be a second order with respect to the concentration of NO2. So in this case, we can deduce that X is going to be 2, right? So if you know the technique, actually for the case of fluorine, that means we deduce Y, we use the same logic, right? We are going to find one pair of experiment in which only fluorine changing concentration, but not NO2 this time. So luckily you realize that experiment 1 versus 3 will be my target, right? Why? Because you see, the NO2 this time doesn't change. The only thing change is fluorine. So in this case, I use red color, right? This time, fluorine doubles the concentration, right? And it will bring to the rate also increase by double, right? From 0.1 to 0.2. If I doubling the concentration, the rate also double. So this time, the double means times 2 to the power 1. So that's why obviously the order in this case with respect to fluorine will be 1. So one with second order, one with first order. So the overall order will be the sum of the orders from all the participating reactants. So in this case will be equals to 2 plus 1. So that will be our choice A for third order in total.